So we turn now to our final speaker, Professor Peter Fox from Rensselaer Polytechnic Institute in Albany, upstate New York, where he's Professor of Earth and Environmental Science and Computer Science, Director of Information Technology and Web Science program, and the Tetherless World Constellation Chair, which I look forward to knowing what that means. The only parking ticket I've ever had has been when I visited Rensselaer many years ago, so watch out if you go there. Now I don't have a car, I'm not in any danger anymore, but all I can say is the train ride from New York City up to Albany is one of the most attractive up the Hudson Valley that I know. So with no more ado, Peter, over to you.
Thank you very much. It's a pleasure to be here. Yes, it's our means of revenue collection is parking tickets, if you've ever been to Troy. Thank you very much for the invitation to speak to you today. A little bit of a disclaimer. So I usually, on my first slide, I usually have where I'm from. I unfortunately omitted it today. So I'm from Tasmania, and I'm half Irish. And today I work in the US, and I was invited by the Germans. So I think that just about covers it all. And I think my job is not to hopefully motivate you anymore, although I've got a few introductory slides to sort of motivate me. I'll give you an idea of what motivates me. And then I'm going to go into, and watch out, I just want to warn you, I have a whole hour. So watch out. No, good, thank you. So my job, I believe, is to give some of my perspectives. I was invited here today. I'm not going to try and tell you what to do, but I'm going to make some observations on how I see activities like RDA have been conducted over the last, in my case, quite a large number of years. So I'm going to start at the global perspective, and I'm going to try and end at the global perspective, and we'll see how we go. This motivates me. There was a conference in March of last year in London called Planet Under Pressure. And that particular activity launched an initiative called Future Earth. And for those of you who are familiar with the world scene, or if you're not familiar with the world scene, there's a very large number of international organizations that have been at work for some time looking at global issues, global science issues, global health issues, global social issues. And they really came together in London last year. And I think this is a remarkable initiative to acknowledge the pressure that our planet is under from a variety of points of view. The trouble is that data wasn't really talked about very much at this particular meeting. In fact, it's a recurring trend in international programs. We all know that data and the things that go around it are fundamentally important to having large programs such as this. But that the conversation around data was absent. And maybe some people would say, well, maybe it's premature, but maybe it's not. But when I look at one of the fields that I've worked in, and I'm sorry if you can see here, so this is just one of many of the climate projections that is available from a variety of different sources of researchers around the world. And just briefly want to highlight, sort of taking a timeline from the early 1900s through a projected timeline to the end of the century, and the potential catastrophic effects that we really don't understand because these are projections. And they're based on simulation data, trying to be ground-truthed in a large network of our sensed environment, both observationally sensed through satellites and in situ and ground-based sensor networks. Right, so this is actually really pretty important. And don't think that people don't understand the importance of the role which data plays in these types of world issues. Many of you will be familiar with the Intergovernmental Panel on Climate Change and the Fourth Assessment Report, which led to an award of a Nobel Prize, Nobel Peace Prize in 2007. And that's all very well and good, but the scientists that were involved in that, some of them at the National Center for Atmospheric Research, recognized the work of the Lawrence Livermore Program for Climate Model Diagnostics and something else, and a large effort called the Earth System Grid, and acknowledged the key facilitating role that the data environment of this international assessment played in actually being able to create the report, bring the international scientific community of climate analysts and modelers together. And so you can get recognition for this, so data is recognised. Now we turn to another international program that some of you will be familiar with, and if you've heard me talk, I bring this up very frequently. Another one is the Millennium Ecosystem Assessment, a very extremely important program that produced a very significant report, assessment of the environment. And if you look very carefully on this page, there's lots of reports and synthesis and frameworks for assessment. And then, of course, there's the all-important link to the data portal, which provides the underlying data to the Millennium Ecosystem Assessment. And if you go to that, you get this. So those in the US hopefully will know why you get this. That is, the US Congress shut down the National Biological Information Infrastructure. Data's gone. Fortunately, the data was replicated and is passed to the Socio-economic Data Application Centre, run by Bob Chen and colleagues, and that it's soon to reappear. So, in reality, it's time to wake up. And when my grad students are with me, they carry a little air horn and sort of set it off at this particular time. But it's time that we really woke up to the significance of the data challenge that is in front of us. And we're talking about research data, but I borrowed this slide from a colleague of mine at NASA, which points to the highly challenging pyramid reflected here. The data has lots of uses. And in this particular pyramid, you'll see that there's layers from the science-attentive public up through museums, educators, all the way up to decision makers. And whether you like it or not, the things down here really are less strategic, and we've heard about that. And as they go up, they become more strategic. And you ask, where are scientists? Well, scientists are being crushed by this pyramid because the demand for these other uses of data is substantially increasing. Remember, this is motivating me. And this particular diagram is one that I happen to like. It's sort of colourful and you can sort of look at all the words on it, but it emphasises that this extra use that we have. So there's forensic use, tactical use and predictive use. There's people in here, there's cyber infrastructure, there's streaming data, there's security considerations, there's social networks, there's all sorts of things in here that really are behind our interest in a world scene in data. So what I want to do now is run through 5 things, 5 perspectives that I think are important for RDA in terms of how. So the first one is I believe you should work as if you have already succeeded. And this actually is quite important. I've seen many groups, many alliances, many discussions who don't take this point of view, that it's, oh my goodness, look at the task that we have in front of us. So when you're going through, when you're having your working groups, when you're having these discussions, pretend you've actually succeeded. What would that look like? How would your discussions unfold then? Who would you go and talk to actually implement and do the things that you've been talking about? It's a very different perspective and point of view. So how do I want you to succeed? So say in 10 years. In 10 years, data is a first-class citizen. So this audience should be old enough to know who that is. All right, so I'm sorry, it's a little US-centric, but everyone's seen Star Trek: The Next Generation, and data is a first-class citizen. And to go a little bit beyond that, what that means for me is that data is an object of conversation. It's not just scientific papers we talk about, it's not just a view graph that we talk about, but it's actually data that we talk about on a daily basis. And that you can see people in society starting to talk about information, but they're not quite yet talking about data, but they're starting to get there. And I think this is something that a Research Data Alliance can definitely assist with. And we have discovery science. Discovery was mentioned earlier. And we have abduction. And I don't mean the criminal kind of abduction or the alien kind of abduction, but it's something that we've known about for a very long time. If you grew up in science environments, it's the way we sort of learn to do science. It's by intuition. It comes prior to the classic approaches of induction and deduction. So the induction is sort of the data-driven one. The deduction is theory or model-driven ones. And it's got this really uncomfortable colloquial name, to have a hunch, a gut feeling. That's really how majority of science is done, just true discovery science. And someone's already mentioned big data. I'm happy for that. And I call it sort of large-scale data. It's certainly true that hunches largely arise for having people in the loop, not outside the loop. And I think this is an important thing as we think about research data and activities, is that we cannot leave the people out of this loop. Because to get hunches, we start to need to consider things such as this. So we've got our world of our head and our intelligence, the observations of the world. We've got logic, reasoning, plans. But to invoke abduction, we need instinct and intuition. We need self-conscious and immediate capabilities, and we need emotions and memories and images and visions and dreams, and most research people just try and avoid this stuff here like the plague. And in fact, a lot of the intellectual discussions tend to leave a lot of this out, and a lot of our information systems that we've developed have built these capabilities out of existence. We have to stop that, or in 10 years we have stopped that. And we pay attention in 10 years' time to the ecosystem of science, in which there are many things we need to be able to do around data, information, and knowledge, which I'll come back to a little bit more. We need to be able to integrate it. It needs to be integratable, it needs to be citable, it needs to be identifiable, it needs to be explained and justified and verified. There needs to be accountability and transparency. And these are the elements that allow our scientists to, in fact, undertake and conduct abductive science. Confirm, refute, deny research ideas, and collaborate. And support this notion of abduction as well as induction and deduction. I'm certainly not indicating that induction and deduction should disappear. But we've got to open up our research enterprise. We've got to open up our application enterprise very, very substantially. To go a little bit further, in 10 years, I hope the word data science doesn't exist. It should just be science. That if data is a first-class citizen and we're having conversations about it and our educational environment has changed so that data is fundamentally taught, as is the use of instrumentation or experimentation or the writing of computer codes, it's so fundamentally built into everything that we do that we just call it science again. And metadata, in 10 years' time, is an old-fashioned word. We don't use it anymore. We sort of look back and say, oh, that's what we used to call it when we didn't know what we were talking about. I want metadata, the term metadata, to disappear. And many of my metadata colleagues hate me saying that, but I'm sorry. If we have to look forward and revolutionize our data environments, this is the perspective I think we have to take. All right, number 2. It's 2013. You could yawn a little bit at this point. And I'm glad John said it before me. It's not, I did have in here, it's not about data. It's not about data. And I put in the just last night because I didn't want to particularly offend anyone. Data is the name of this particular alliance, but I have to show my favorite slide. It's my ecosystem slide, in which data is part of an ecosystem that resides alongside our representations of data and our organizations of data in terms of information in a given context, and it relates to knowledge. in which we do have conversations and we integrate and we add experience. And most importantly, there is not a linear progression from data to information to knowledge. That is wrong. That's my assertion. And that in fact, sometimes knowledge is information, sometimes information is data, and it's the interaction, the ecosystem aspect of this, which is extremely important in a research enterprise, in an application enterprise. And this is really important because we have particular ways of treating data, we have particular ways of treating knowledge, and we have particular ways of treating knowledge. We have theories of this, we have theories of this. We don't actually have a theory for data. And I'm not even clear we have complete theories for how we make these transitions. Now, I'm not sure that the Research Data Alliance should take on this task, but it is part of the consideration in how we develop best practices, seemingly, potentially in isolation of these areas, and these are potentially done by different communities. Typically the data community, the information sciences community, and the computer science community. We need to really pay attention to that. Because what we have in reality, oh yes, and it was mentioned that much of these forms come unstructured these days, and so we need to pay attention to the structuring of these different forms of content. So one way to think about this, and many people sort of think, well, if we could only think of data as infrastructure, there's a trend emerging, in fact, out of Australia, to treat data as infostructure. And this is an idea I've been talking about, and this is sort of a very typical example of what that actually means, is we have this mixture, we have all of these components of streaming data, we have people involved, we have smart communication networks, we have information sources, and we have data sitting underneath. This is the ecosystem, this is the world in which we live in. And in fact, it's the people in this ecosystem that sort of really depend on this infrastructure. Keeping people in the loop to do true discovery and true interaction means that we need to pay attention to this type of approach. In addition, as we sort of now look at the blue arrows, we love to draw arrows on charts like this. I do it all the time. These arrows are the way in which we get these sources into some integrated means of a human viewing and understanding and potentially making decisions. So what this relates to is how we mediate and how we mediate exchanges. And this is one of my favourite slides at the moment. It's from a cyber learning report from the National Science Foundation, terrific report. And Christine Borgman, whose name I have misspelled, please don't tell her, was the chair of that panel. And I just want to spend a minute on this because I think it's important in terms of thinking about data, information, and knowledge. And what it displays is 5 generations of mediation. Cultural mediation, symbolic, communication, network, and cyber infrastructure. With, at the top, the manifestations of these mediations. So, in person, creating artifacts, sending artifacts to you, communicating between the artifacts, and then sort of the 5th generation that we have existing right now, we have collaboratory, social networking, Web 2.0. Now, usually in a generational plot, the past generations' significance are diminished. But the problem we have here is that we have all of these generations operating at the same time. And that places significant burden on being able to use research data. And the fact that the complexity of mediation is actually increasing should also be of significant concern. And there's a 6th generation, and it's coming. And I'm not going to tell you what it is. You'll have to ask me. But I'll give you a little hint. So, and how does this mediation work? Well, what it does is it mediates between a plethora of data and information sources, and this is just one example I pulled. Thank you, Andy, for generating this some time ago, around a virtual observatory for the study of carbon in the Earth's environment, where we have science applications, policy applications, ecosystem applications, who all need to sort of draw on this same set of data, information, knowledge sources in an integrated way with interoperability. Hey, I'm the first person to say it so far this morning. I was hoping someone else would. So this idea of mediation between the people who generate data products, information products, and those who use them is actually a really important thing. And something like the Research Data Alliance, in terms of structuring and considering who is going to use the data, information, and knowledge products, I think is potentially very important. So if it's not just about the data, what is it about? Well, luckily you have it in your name. It's about the alliance. It's really about the alliance, and I've had the privilege to be involved in a number of them. So we have a number of alliances, some of which you know about. The IVOA, I think, is a good and very interesting example, all the way down to things like TADWIC. We had GBIF mentioned. There's just too many. I didn't have enough room. And I've also been involved in the Earth System Grid Federation. And there's, I think, a really interesting hallmark of all these alliances. And I'm up here and I'm going to say it. And that is, the majority of alliances that I've been involved in have been most successful when there's no money on the table. Now, that doesn't mean that people are not funded to do components of this work. But at the actual alliance level, volunteerism, self-motivation is the hallmark of successful alliances and collaborations. I'm not saying you should do it that way. I'm just telling you that is my observation. And you can stone me later for it. What I think you do have, though, is a network. And here I want to sort of divert just a little bit and talk a little bit about modern science networks. They too are ecosystems. And in something like an alliance, and at the US meeting earlier this morning, we talked about a lot of other activities that are going on in the data space. Project activities, national activities, federations, all sorts of things. They make up an ecosystem of data alliances. And in fact, the best ecosystems need diversity. They must have diversity. There should not only be one dominant species, otherwise ecosystems are not viable. There should be many types, and most importantly, ecosystems and networks rely on partnerships, coordination, people to do work, and the dependencies. And here's a sort of a little interesting diagram that I want you to just stare at for a little bit. This is a little cartoon of what's called a scale-free network. And in scale-free networks, one of the very important factors are the things, and the blue nodes I'll come to in a minute. These are the dominant activities, so these might be major alliances. These little guys in between are what are called the weak nodes, weak interaction theory. So what this means is that many organizations, let's just take these blue dots as organizations, try to engage directly. And in fact, that creates a rigidity in the network that may not actually serve the purposes of either network. And in fact, it's fairly well established in network theory that these weak interactions, and sometimes these are individuals, sometimes these are boundary organizations, sometimes these are projects, are a really effective way for parts of the network to retain their diversity and their distinct contributions, and as well for the network as a whole to thrive and grow and actually make some progress. So I'm putting this up as something for RDA to consider as where they sit in a network of data information activities. So what are the blue things? Anyone know what the blue things are in a scale-free network? Hubs. Well, we call them supernodes. So supernodes are people. It could be you. It could be your organization. It could be computational infrastructure. It could be data and information services. And the important thing in these networks is understanding the roles, responsibilities, and delegation to smaller nodes around the supernode. So just, if you're not quite sure what this means, think of the internet. The internet is, to a certain extent, a scale-free network. The supernodes, one example of supernodes on the internet and on the web, are search engines. They aggregate a lot of information around each of these search engines, and there's not one, and there's not 100, There's about 7. And they, in fact, interact through these weak nodes in between. They don't interact directly, partly because they're competitive. So I just want you to keep that in mind. So what I'm talking about here, and maybe many of you know this, things like RDA are what we call a socio-technical system. And that refers to both the sociological aspect, the people, and the groups of people involved in this quite diverse group, and the technical aspects. And I don't mean technology, but the technical as organizational and process aspects of it. And I encourage RDA, if it hasn't done so already, and I don't actually know, is to think of them as a socio-technical or a socio-ecological system, as it's now called. And there are many, many factors about the structuring and organization of virtual organization of such a group, which can be really enabling if you follow the best practices, or really disabling if you don't follow them. And so you start to get, this is a particular model, this is the SENS model of how all the components in a network might come together. So you've got natural adaptation, and you've got adaptation of the network, you've got behavior, you've got changes in technology, you've got changes in governance, and you've got culture. And at the intersection, you have an exchange of these. And I encourage RDA to look at how it interacts, how it might be structured, and how it actually functions in harmony, hopefully, with other components in other networks. And RDA is likely to be a complex network in the virtual organization sense. Complex networks consist of technology, communication patterns, and organizational structure, and the degree to which informal communications play a very, very important role in these types of organizations. It's very important that more communication is exchanged, and means of recording and preserving and disseminating those informal exchanges is very important. And if you don't know anything about virtual organizations, this is probably the most important thing that I think I can tell you. That members of something like RDA assume well-defined roles and status relationships within the context of the group that may be independent of their role and status in the organization in which they work. This is not my day job. My supervisor doesn't understand why I spend so much time working on this particular community activity. And the lack of recognition of this disconsonance between roles and responsibilities between an activity like this and your day job is extremely important. There's a whole set of other literature on virtual organizations that I could go through, but I won't, but I'm happy to share some of that with you. So let's come to number 4, and that starts to bring us back to the world scene. And what I would like you to do is to be aware of opportunities and needs for what I call vertical integration. So we heard a little bit earlier about national and regional discussions around data. At the international level, there's been activities around coordination for data refocused, let me say, because real coordination for data started occurring in the international scene in 1957. And we sort of forgot about how important it was. And we sort of remembered about 50 years later in the 2007-8 timeframe when a series of international celebratory years of the International Geophysical Year occurred. Polar Year, Heliospheric Year, Year of Planet Earth. There has been significant attention at the International Council for Science starting back in before 2004 with a priority area assessment, a strategic coordinating committee on information and data, another committee on information and data, and there's various reports that have come out for those. And if you haven't seen them, I really encourage you to take a look at them, because the idea was in fact to assess and synthesize all the things that were going on around the world and across all disciplines, at least under the ICSU umbrella. And Ray Harris and I have just published hopefully a fairly readable article about this in the Data Science Journal. And so, you've got about 10 people coming together and writing fairly important reports as far as we're concerned. We had another committee that was a follow-on to that met in Paris. There's Kathleen, there you are, Bob. There's a bunch of people here from this. You'll hopefully recognise some familiar faces in there. And we're all smiling because we just had a lovely Parisian lunch with wine. And I'm not going to run through all the recommendations, but I just want to hit on a few that are potentially quite relevant to this particular gathering. And these are slides that I've taken directly from a presentation I gave about a year and a half ago at the launch of the World Data System Science Assembly in Kyoto. So in there are things like best practice guides and the very strong recommendation for adoption by nations and unions through their data and information committees, and a guidance to say ensure that the guide is followed and is adopted by all new ICSU projects and programs. How about that? No one's done it. No one's done it. Why haven't they done it? Adoption, why haven't they adopted this? It's pretty straightforward. We were very insistent. It was ratified by the ICSU General Assembly. Why hasn't anyone done it? Well, it's a cultural thing. What's next? Big emphasis on open access. All right, SCCID report. This was 2011, right? Very little movement on it. OECD guidelines. Fantastic stuff. It's all there. Why is no one adopting it? It's pretty clear. It's adoptable. Potential role for organisations such as RDA to carry that to adoption and put them into practice. And some more challenging ones. Engage actively with publishers, library community and scientific researchers to document, promote best practices, handling, blah, 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 all of this. Another potential role there. So I'm not going to just leave you with what's recommended and a question of why it hasn't been implemented. 5 years ago, I went to the home of geography, Villa Salamontana in Rome, in Italy, gathered together at a little summit of the international years. And we had 3 days of very interesting discussions. And at the end of it, I put together this chart. And it's a lot of words, but it was a working session. I've reproduced it exactly as was presented in 2008. And what I said was, well, we've got all these different levels of activities going on, all the way from the working level, through national levels, through mission and production agencies, through programs, through international associations and unions, through international alliances, and you can probably put RDA in here now, and then global and inter-union. And I gave some examples. This is not meant to be fully representative. It's just meant to demonstrate what might occur there. And I said there's a really interesting thing going on, and that is there's two primary characteristics that we saw in each of these activities. And one was the degree to which these particular activities show leadership, putting out new practices, implementing them, and the degree to which they take responsibility for them, commonly known as governance. And I've put here, leadership and self-governance. Leadership, but not unclear role for governance. Lots of governance, but unclear role for leadership. Programs, so on, and all the way down to global and inter-union activities where there's an authority, but they were not necessarily exerting leadership. And you notice that I left the international alliances without a label. And it sort of struck me about why I did that, and that was because it wasn't quite clear that you had either. And I think you've got to have some. The problem, of course, the reason why we don't get the adoption is that there's all sorts of discontinuities between these working levels. They occur for many reasons, and this is somewhat of a generalization, but it's largely true. And I think being aware of this need to vertically integrate, percolate things from the bottom up, from the working level all the way through these many different levels, as well as the need to do things from the top down, where there are authorities and other sorts of mandates coming through. this vertical integration is something, there are opportunities for it, there are often needs for it, and by and large you can point to failures in our ability to go off and implement the really good things we think we should do to these types of gaps. And I think this type of analysis is probably worth doing again in the context of something like RDA. I'm not giving you any homework. All right, number 5, which is the last area, and that is the culture must change now. I couldn't get a sound on here, so it has to change as well as how we think about the paradigms for which we do science and build technical capabilities and so on, and use metaphors. And I'll just a little plug for the paper that Mark Parsons and I wrote recently, which talks a lot about metaphors in data and data science. So the first one is to challenge the heroic science paradigm. And what this largely means is a substantial amount of science and research is still done in the heroic sense. In fact, in the very isolated sense. And I'm not going to spend really very much time on this because I think this is a relatively well-known idea to this audience, is that, you can take 2 years to analyze a data set and produce a paper, and that still is deemed acceptable. And yet, the poles are melting and the polar bears are about to disappear, and we need to change the way in which we do things. And a lot of it is around the incoherent way in which we approach our data environments, our information environments, and our knowledge environments. So that's part of it. This is sort of changing the conduct of science in some sense. But there's another one, and I know I'm going to get myself in trouble for this one, and that is we need to challenge what I call the heroic technical approach. So I go to lots of meetings like this, and people love to talk about architecture. Data architectures, reference architectures. Please stop that. Because when I teach this, I say, let's go back and look at where the term architecture really comes from. So in real architecture, form follows function. So here are 2 forms of bicycles. And I think you'll note that the form of them depends on the function. And there's a lot we can learn about the art of expressing a model or concept used in activities that require explicit details of complex systems. So think about functionality, think about capability. Please don't get all caught up in architectural considerations. They can come in the implementation stage. The next thing that's going to be needed for change is around standards. Now, I'm not suggesting that RDA creates standards, but I want to point out an important thing. The creation of standards is significantly a technical activity. Where this happens, there's probably not enough standards yet, but there's a really good amount to work with. So I encourage RDA to work on adoption. And that's largely a cultural activity. And remember, culture eats everything for breakfast. So RDA as a potential role for the change in culture around how we think about data, how scientists think about it, how technical people think about it, how our colleagues in library science and computer science think about it, is really important, because the thing is, it's around adoption. And then we might find out what's really missing and what really doesn't work, instead of going off and continuing to invent things that someone else has. And what I want to sort of put forward in terms of, I had to show this, is to start to look for methodological approaches. And this is one that I'm responsible for with my colleague Deborah McGuinness. I'm not going to explain it, I just want to flash it up, because for me it emphasizes that understanding what we call a use case, which is a description of a scientific scenario and those who are involved and what the goal is, what you want to actually do, is much more important than thinking about technology. And that should drive the types of development that we might do, the choices we might make about adoption of particular approaches and technology, and that we really want to get things out and build things and put them in front of people very, very quickly. Get their feedback rather than thinking we're going to be able to take 2 years and develop the ultimate thing. So I just want to put that out in front of you. All right, second to last slide. So my perspectives are work as if you've succeeded. And if you feel hesitant, just pretend that you've succeeded. It's a good way to start. Act as if you have. Remember, it's not just about the data. I know many people here love data, but it's about information and knowledge and the interaction between them. And that it is really about the alliance and thinking about what an alliance and an alignment really means to you, your organization, your peers, the projects you work with, your funding agencies is really important. To be aware of vertical integration needs, i.e. the rest of the world, the people that are outside this room, and how, on your part, the culture can change around you now, from now on. Because RDA has been given a remit which has a great deal of uniqueness behind it. The previous speakers this morning are not typically the people who would precede me in a talk such as this. And I think you have a very rare opportunity to do something really, really important in concert, and I mean concert, as in orchestrated, with the other organizations, the other activities, the other groups, the other people around the world. So, going forward, BRDA, and I had all these different things. I had my acronym generator going, and I thought I had some really edgy ones. But so be ready, be dynamic, and be active. And here's what you need to have in mind. You need to scale. So these rooms that I've been in these international committees, there's about 10 people. There's about 100 people here. It doesn't end here. It has to go to 1,000 people. It has to go to 10,000. You have to reach 1 million people to really make this work. And thinking of scalability of what you're working on and suggesting and implementing is really important. And now we be headed to lunch, maybe after a few questions. And I want to thank you very much for listening to me.
Thank you very much indeed, Peter, for many